Okay, so let me talk to you a little bit about what normal distribution is. And we'll start off with an example. Let's say I measured the height of all the 30-year-olds in the country. And I measured their height in centimetres, but I went into a bit of depth and I measured it quite accurately. And let's say I grouped those heights into really, really small intervals. So maybe one of the intervals was something like this, 160.1 centimetres, and let's say 160.2 centimetres. I measured it really accurately and I grouped them into really tiny intervals like this. Now, let's say I got the data and I drew a graph from that. So I had frequency going up. So maybe in this group here, maybe I had let's say close to 1,000 people in that group. Okay, maybe 1,000 people in here. And so I drew this graph with frequency going up and the heights, running along the bottom like this. Okay, and there'll be the heights in centimeters, and I drew really, really tiny bars to represent this group here and all the others, and I joined up the middle of each bar. Okay, and I made a nice smooth curve with the middle of each bar. Then the shape of it would look something like this. It would be this sort of symmetrical bell-shaped curve like this. So this should be perfectly symmetrical, but it's not. Not drawn very well. And also, if I actually cut this in half, if I find the line of symmetry, okay, and I found this particular height on my x-axis here, this particular value here, this would actually be the mean. That would be the mean, and the symbol we give for the mean in the normal distribution chapter is this mu. It's a Greek letter. It looks like a U but with a kick at the front, and that would be the mean. That would be the average height. That would be smack bang in the middle. Okay, and it chops the data in half. So I'd have 50% of the population here and 50% of the population here. All the really short people will be there, and all the really tall people will be there. And the majority of the people will be somewhere in this region here. Okay. And it's called a normal distribution because this sort of shape appears in lots of different things. This sort of symmetrical bell-shaped curve here. For example, it works with if I got the weight of all these people and did the same thing, I'd have this as well. It's a really common shape, this distribution here, and it's so common that's why we call it the normal distribution, because it's that common. It's normal, and you'll find that the mean, the average, will be in the middle as well. That you could chop it in half, and then that particular value would be the average height. So in this chapter, all you're really going to be doing is working out particular percentages. Well, not these obvious ones, but particular percentages, and maybe working out probabilities as well, and also key values along the x-axis. So for example, you may be asked to work out, well, what percentage of the population is above a height of maybe 170 or something like that. Okay, and so you'd have to use your GDC to work out what percentage of the population would be here, and so on. Okay, right, but let's go ahead and look at a example to do with all this, right? Okay, so here we have this question. It says the chest measurements of 18-year-old footballers are normally distributed. So when you see that word normally distributed, it means that it's got a, oops, let me scroll down a little bit. It's got a bow, let me go back up a bit, a bow-shaped curve to the distribution like this. Like, oops, let's see, yeah. It's a nice, smooth, symmetrical curve like that. And it says with a mean of 95, that means if I go onto my x-axis, and I'll find the middle of it, of this curve here, that would be 95 centimeters. That would be the average measurement. Okay, right. The other important piece of information they give us is the standard deviation, which is 8 centimeters. If you're not sure about what standard deviation is, look back on the previous clips. In statistics, the standard deviation is just basically a measure of spread. It's the average distance away from the mean, and it's telling us that's 8. Right, now to work out these questions, we're going to do part 1 and just part B here. You need two crucial pieces of measurement for your calculator to do the job. Okay, you need to know the mean okay, which they tell us is 95. Okay, 95, and you need to know the standard deviation, lowercase sigma here. That's the symbol for standard deviation, and that's 8. Right. First question is this. Okay, 95 is in the middle. It says find the percentage of footballers with measurements between 87 and 103. Okay, between 87 and 103. Now, 95 is in the middle, and if you take 8 off 95, you get 87, and if you add 8 to 95, you get 103. So we're looking at 87 being somewhere here, and then roughly the same distance to the other side. That'll be 103. Okay, and we're trying to find the percentage of the population that's in this section. So what percentage is in here? Okay, right, and the calculator does all the hard work for us. So let's go ahead to our calculator and work it out. Okay, so you are on either using the calculate or this calculate down here, and we go to menu, probability, distribution, and the second one down, normal CDF. Right, it's asking you for 4 things: the lower bound, upper bound, there's your mu, your mean, and your standard deviation. Right, the lower bound, we want to know the percentage between 87 and 103. So your lower bound's 87 and your upper bound's 103. Your mean was 95 and your standard deviation was 8. Press OK. Right, it's telling us 0.68. Let's say 0.683. 0.683. Okay, but this isn't a percentage, and this is a percentage as a decimal. So really, that equals 68.3%. So that means out of all these 18-year-olds that were tested, okay, measured, sorry, 68.3% of the population are between 87 and 103. That's how many are in that little bit here. Okay, right. Next question. We're going to do the same thing here for this particular question, but it's asking us for the probability instead. So the first question said percentage, but this is saying what's the probability. And so what would be the probability if one person was picked at random? What would be the chance of them being somewhere between 87 and 111? So 111 would be another 8 on from 103, so that will be somewhere about here maybe. Okay, let's say that's 111. So what's the chance of the one person being picked and their measurement being between this figure and 111? So what's the chance of them being anywhere in this sort of large section here? Okay, so let's work that out. Let's work that probability out. Again, we go to calculator, menu, probability, distribution, normal CDF, and right, we do the same thing. Our lower bound this time, it's the same as before, 87. Alright, our upper bound, we're looking at 87 to 111, so 111 there. Right, our mean is 95 again, and our standard deviation is 8. And press OK. So we have 0.819. Well, let me write here, 0.8, what was it, 819. Okay, and that's probability really. And the only difference with this question is when it asks for a probability, you leave that as it is. Okay, so and that's the chance that if you pick one person from random, their measurement will be somewhere between 87 and 111 centimeters, and that's all you need to do really. And that's it. That's the chance of it. Chance of the person being between those two. And then this is sort of the basic stuff you're going to be doing in normal distribution, really working out a percentage or a probability. The next 2 clips look at working out expectations, and the one after that is about working out quantiles, working out particular values down here. Okay, and all of it can be done on your calculator. So remember, this curve is symmetrical, and the mean's in the middle, and you need to know these 2 pieces of information to work anything out. The mean and the standard deviation is crucial.